Alright, so let's continue with our project one. So today we're going to show basic how do you model space frame. The dimension would be 3 meter by 1 meter high, but you got to study how it is being designed. Space frame is a framing structure that is designed not to have any bending. Bending should not happen in the main source of deflection. So if you design space frame properly, you should only have either your members in tension or compression. Your members should not be bending too much. For example, if you look at ladder frame, there's nothing to capture the bending load. So the frame itself has to bend and deform downwards. The box frame is intermediate, however the space frame main the cross members should withstand all the bending loads. So let's try and model this thing. So go to file, create a new part. Make sure your units in millimeter, and then you have to create maybe from the top plane, and then sketch a rectangular. You can start from the origin, and then we can do a dimensioning. This is 1,000. This is 3,000, and then I can exit, and then I can extrude by about 1,000 or so. Then we're okay with this one, and then I can cut sketch here, and then control 8. I have to create my you just will snap to the middle, and then this is my cut profile. So the cut profile have to close off the feature, and then I can exit, and then I can extrude cut. So this is my space frame. So next thing I should do is I should go to sketch, and then click this one and go to 3D sketch. Once I click 3D sketch, and then I can select one of the lines, this one, and then I can select Control A. So we select all, and then I just hit convert entities. So I have created a 3D sketch. So now I can exit my sketch. I can hit this one, exit sketch, and then I can hide my boss extrude. Right click, hide. So this is my main structure. So I have to add certain more beams. Add more beams in order to create the main space frame. I can start to do some welding already if I want. I can go to weldment, create a structural member. Obviously this one is good enough. Maybe I want to weld this one, and then this one, and I can continue. I cannot, I have to create a new group, and then this one, new group also. So if you don't like the way it is being joined, you can adjust it. How do I adjust? This one currently is being joined like that. Do you want it to be that way, or do you want it to be like 45-degree angle or 60-degree angle? You have to adjust it at the bottom here but in order to do that, I gotta delete certain things first. Delete this one, delete this one. Let's try, maybe you can do it. New group. This one, can I adjust? Apparently I cannot adjust, huh? Becomes like that only. It's fine lah, we accept first lah. Oh, currently everything is like that, huh? It's not. Oh, that's why. You have to weld your things properly, kalau kamu tengok kat sini kan. If I look here, this model is actually welded the bottom frames first. So if you weld the bottom framing first, and then it will go up as what it is lah. So maybe the sequences of how you weld your structural member is very important also lah. So I gotta delete this one. I gotta delete this one. The next thing is I should weld this one. Then it's okay. Oh, so I gotta add one more pole here. 3D sketch, lines, this one to here, one more line here to here. It should automatically snap lah. Oh, like that. Another line, right? There's another line connecting these two. Why is it not behaving properly? This one is not right, huh? It's not snapping properly. Here to this one, gotta trim it. It should be in between lah. Kalau nak tengok betul-betul kena tutup ni lah. Right click ini, hide sekejap. Keluar kejap. Hide this one. Rectangular tube, hide. Then you know you are drawing it properly. And continue 3D sketch. This one to here. And then put more beams lah. So another one here to here. And next one here to here. And finally, we gotta cross it from top all the way to the bottom. And over here also, sketch line from top all the way to the bottom. So bagus kita draw the structure first lah, and then kita welding ya, according to what we want. Welding bottom dulu. Maybe I want to add weldment here first. Exit structural member here. And then ini dia tak sambung properly configuration. Kalau macam dia tak sambung properly, mungkin kamu kena edit yang existing ni, existing punya rectangular tube ni. Edit dia, create a new group. Oh, I don't have it here. Sebab 3D sketch ni saya buat selepas kan. So rectangular tube ni kamu boleh tarik dia letak bawah. So 3D sketch, 3D sketch, 3D sketch. Sekarang bila saya edit yang ni, dia akan ada. Kamu kena drag and drop. Sebab tadi feature ni dia duduk kat atas tau. Duduk kat atas kan. Duduk kat sini. So saya buat feature ni dulu, baru saya buat sketch. So if I want to edit this one, it's not available lah. The sketch is after. So you can rearrange the features. Click it, hold, and drag it drop at the bottom. So meaning you created all the 3D sketches first, and then you do the rectangular tube. Now I can edit. New group. Well, this one, it should cut off properly lah. It is cutting off properly because you're doing it concurrently. Add more tubes, I suppose. Edit feature. New group. I think the vertical pole boleh letak. Like so. And then you can edit some more. Create the horizontal cross member. Macam tu. And then finally you do the 45-degree angle or 60-degree angle. Right click, edit. Edit feature, new group, and this one. Is it behaving properly as we wanted it? Or not? This one. This one. Cannot, new group. This one. It's trim off like that. It's not behaving properly. So gonna play around with it a bit. I don't think there's much effect to the results, but this one is affecting the design itself. How you are welding it. Contohnya benda ni kan, kalau kamu nak bagi dia jadi horizontal, kamu kena carilah. Which one was it? This one kah? This one. Ini dia macam vertical kan. Kamu kena edit feature, tukar dia punya profile, alignment. This one 0 degrees. Try 90 degrees. Can kah? Tak jadi pun. How do you change the condition, make it? Kena carilah dia punya profile. Group 5 ni alignment dia, alignment to the horizontal axis, rotation angle ni, try 90 degrees boleh tak? Dia jadi horizontal lah. Ni macam tu. So sequences kamu welding tu lah kena berhati-hati . Ini dia join dia tak okey . Dia tukar untuk semua . So tak bagus juga . I gotta undo this one. And another undo. Sebab yang ni pun dia dah tukar. Nak tukar yang ni saja kan. Dia kena tukar yang ni je lah. Right click ini, edit feature. Yang ni yang kena tukar 90 degree. Betul ke ni? Teng. This one. Edit feature. Tapi dia highlight yang bawah ni sekali . Kena cari yang betul-betul lah yang ni. Group 5. Group 5 only you want to change to 90. The rest you don't want to change. Yeah. Ini kalau nak settle kena check balik lah. What do you want to do for the end? Which is this one . Right click, edit feature. Group 6 . No, group 7. Group 7. Dia punya the way it is being joined, you gotta change that one. I cannot see here. Not much I can do here. Kalau nak edit boleh lah, tapi kalau tak edit pun tak apalah. Because in terms of finite element modeling, it doesn't matter lah so much. Sebab dia semua akan model jadi beam element lah. So can continue. edit feature, put more welding one here, and then another one here. Can I add one more here? Cannot. New group, last one lah. And finally this one. New group also. So it's kind of tedious lah to model, tapi belajar lah. Finally kita nak tukar ni lah, tukar dia punya section. Go to sketch 11, right click, edit sketch, and then tekan Ctrl 8, and then edit this one. Your profile should be 100 by 80 with a thickness of 3 mm. So this one change to 100. This one is 80. Currently the thickness is 8. Change this one to 3. This radius is 16, is okay lah. Maintain. Click on OK. And then you can exit. So the whole thing will be changed accordingly lah. So if you look at the front view, you're gonna see an X. Try looking from the side. It will be a triangle. If you're looking from the top, you can see a pure cross lah. So cross ni is very good when you want to withstand, especially torsion lah. Torsional load, you can withstand a lot of torsional load. So once this is done, you can measure how heavy this thing is by creating a material lah. Material, you can edit material. It is, what kind of material lah? Plain carbon steel. Check this one. 1023. No, I think it's this one. Plain carbon steel. And then click apply and then click close. So kita nak tahu dia berapa, you gotta go to features. No. Click on evaluate. Click mass properties. Kalau kamu tekan the whole thing, is going to be very heavy lah. It's going to be very heavy. So this is not correct because you have this solid, right? This solid ni kita dah dia ada seketui solid kat situ. So you don't want to measure the weight of the solid itself. So solid ni kamu boleh right click, hide dia. Again, go to mass properties. Part 1 ni delete, right click, clear selection. You have to select manually lah. Select manually, it will show you what is the weight itself lah. So the weight is actually 191 kilogram. Just measure the tubing punya weight. So you can compare lah between all the three designs. Which one is heavier, which one is lighter, what are the performances. So once this is done, you can immediately go to add-ins and click on simulation. Don't forget to save lah, save your model. So this is done. Go to here, simulation on the tab, and then click on new study. Make sure it is static. Click on OK. And then you have to go to part and go to cut list. Expand this one. Cut list item 1, solid body. You make sure you have to right click here and exclude from analysis. Otherwise, the solid thing, which is this one, right? This solid thing will be involved in your analysis. If you go to mesh, right click, create mesh. It's going to be meshed together inside your modeling. It's asking you, there are two bodies interfering. Do you want to check for interference? No. The mesh will also fail. So you have to go here, cut list item 1, right click on the solid body, right click, and then exclude from analysis. So once this is gone, you can easily mesh it. Right click, create mesh. So now this is modeled using beam element lah. Everything is connected to each other. It doesn't matter what kind of finishing you have here. Everything is just modeled properly. So now modeling is done. Is the material being fixed? The material kita dah letak lah, plain carbon steel. Ini pun sama, plain carbon steel, semua dah ada material lah. Since we have assigned the material, now you can go to fixtures, fix geometry. Make sure you can hit fix geometry and then maybe secure 1, 2, 3, 4. Symbol setting you can change lah to 300, so it's bigger. And then click OK. And then finally you can put the load lah. External load, create force. Choose this one, which is joints. So you want to apply force here and apply force here. So 2 joints. What are the values? It's asking you for a reference plane. So the pink color one, you have to choose a reference plane lah. So reference plane can be front plane. And then if your reference is front plane, so this is vertical lah. Symbol setting you can change to bigger, 300. I can reverse direction, and the value would be I think 5,000 Newton. Click OK. So 5,000 Newton per item, so total together is 10,000 lah. So now I can run the analysis. Click run. Before that I should save lah. Save as somewhere. Save. And then I can run. So once you've run, you can see the deflection itself lah. What is this deflection? Go to displacement and then click show. Show 10,000 Newton. It moves by about 0.05 millimeter only. So you can compare lah to other structure. So this is checking the bending stiffness. 10,000 Newton, dia gerak 0.0564. So let's calculate. What is the bending stiffness? Let's go to here, maybe add one more slide. Let's print screen. Hit print screen. So print screen your results are. And then paste. And then let's do some simple calculation. So K bending is equivalent to force over, I think, deflection kah? Deflection. Because the unit will be Newton per millimeter. So this equation comes from F is equal to Kx lah. So K sama dengan F over X. Sama lah. So this is the deflection. So force you applied is 10,000 Newton divided by deflection, which is here 0.0564 millimeter. So dapatlah berapa chassis ni punya bending stiffness. Berapa ni? Berapa? 177,000. Macam tu kah? Ni panjang. Convert kepada kilonewton kalau ni. Satu tujuh tujuh 177 kilonewton per milimeter. So kamu boleh compare lah. Sebab kita punya chassis tengok dari atas sama je size. Tapi design saja berbeza-beza. Kalau design tak betul, it's not very good lah. So sekarang kita pakai beam. Nanti kita kena pakai surface lah. Because most of your vehicle structure dia banyak pakai surface, pakai sheet metal kan. But you still following the same procedure. Surface mana yang akan ambil the bending load, surface mana yang akan ambil the torsional load. So this is one calculation, bending stiffness. So next we have to change it to torsional load. So in order to change the torsional load, we just have to figure out a few things lah. Fixture ni kena ubah sikit. Right click, fix one ni, edit. Kita tak perlu pegang 4 tempat, kita buang lagi satu lah. Maybe join 27 I can remove. So tinggal 3 join saja yang saya pegang. 3 joins, and then load saya kena ubah. Right click, edit definition. Change this one to, I don't need to be at the top. Delete this one. Ini pun delete. Saya sekarang nak apply load dekat sini lah, dekat join ni. So instead of pushing down, saya nak pushing naik atas. Kata saya letak 10,000 Dan dah saya tekan OK. So pegang 3 tempat, tolak 1 tempat. Macam yang industri duk buat lah. Ini adalah testing yang orang buat dalam, dia push ke bawah boleh, push ke atas boleh, sama je lah. So pegang 3 tempat, tolak 1 bahagian, and then you can immediately run this. It takes a few second. Cuma kamu nak tengok dia dari pandangan depan lah. Tengok dari pandangan depan, macam tu. Ini adalah deformation scale factor dia 238. So kita nak tengok displacement, show. Dia gerak 1.26 mm. So mari kita print screen dia. And then let's create another slide. And then let's paste this one. Now let's calculate. So original is like that. Now it is bent that way. This distance is actually 1.26 millimeter. Berapakah theta? Sekiranya sini adalah 1000 mm. So you can use tangent theta sama dengan 1.26 divided by 1000. Berapa degrees? This load that you give is actually 10,000 Newton. It's gonna be, I'm not sure. 0.72 degrees. 0.72 degrees. So change to torsional stiffness. KT, which is torque divided by degrees lah. So torque adalah 10,000 Newton meter. Sebab jarak ini 10,000 Newton, jarak ni 1 meter, 10,000 Newton meter lah, bagi dengan 0.72 degrees. So kita dapat torsional stiffness adalah unit dia Newton meter per degrees. 10,000 divided by 0.72. Oh, 0.072, bukan 0.72 0.072. 10 exponent 3 divided by 0.072. Per dia ni banyak Ada engineering 8. 138 138 888 sangat stiff lah. 138 888. Ini yang saya dapat. So kamu boleh test sendiri dan kamu dapat lari sikit no problem. So you can compare between the three lah, between the three designs. Itu je lah the first part of our project, which is studying how chassis should be designed. So now later on, if we changed, for example, let's see, widescreen. Sekarang kalau kita terpaksa buat surfaces kan, surfaces box yang withstand all the loads. You've got B pillar here, you've got a rocker beam here. Kamu boleh roughly understand lah with all the structures yang terlibat. Obviously it's more complicated lah once you're using surfaces and shells, but you have some idea lah about torsional rigidity and bending stiffness. So screenshot saja jawapan-jawapan kamu and then you should be fine lah. So stop.